Hi, this is Tim Prigon, and this is my first YouTube weather video for hyperlocal extreme weather. And hi, this is Tim Prigon, and this is my first weather video for hyperlocal extreme weather. And what I'd like to do in this video, a couple, three times a week, is just kind of show you what we do when we forecast the weather and analyze the maps and all the different levels. And I'm just hoping that I might be able to teach you something, of how weather works and why things happen. I find it fascinating, and I hope you do too. But on this first video, what I really like to show you is just the weather sites that we use to forecast the weather. Back in my day, we didn't have any of this computer stuff. We actually had to hand draw everything. So this is completely different than what was 30, 40 years ago. But just wanted to go over the models here and the sites. So the first site that we go to, and this is my favorite site, is called COD Meteorology. You type in COD Meteorology in your Google search, and this is what comes up. And when you get this, you'll want to go to weather data, and then you'll want to go to numerical models. And then this will give you the models that this particular site has. And they're short-term models. These usually go out 18 hours, uh, except for like on the 0Z, the 6Z, the 12Z, and the 18Z, which is 6 o'clock, midnight, 6 a.m., noon in the wintertime. And then it moves ahead an hour in the summertime. But they'll go out to 48 hours, these short-term models will. Medium range models, the NAM goes out 84 hours. That's the North American model. This is a high res North American model. It's called the 3K, and this goes out 60. And then we have a short term Canadian model that goes out 84 hours too. Then we got the long range models, which goes out 10 to 16 days. This is the Canadian model, the European, the American model, and then the CFS. So that's the first site that I like, and I like this best because it's got the best graphics. But the other sites have more models to look at, like Pivotal Weather. If you get on this site and you're not a subscriber, it can be kind of a pain because ads pop up all the time. But this site has a lot more models that we can look at. So it's got all the same models that the COD does, but it's got a lot more, uh, let's say, short-term models, more high-res models, which are good for during severe weather and like when snow is basically within the next 12, 18 hours. These models are very good. And then we also have two other long-range models that are very good for snow ice, and that's the Icon and the UK Met, which is United Kingdom Meteorology. So those are all the sites there that we like to look at. And then the last site is called Weather Bell. This is a subscription site. It's a pay site. So, and this has got quite a few more. It's actually got, a national blend of models, which it takes every model out there, select models, and basically blends them all together. And it comes up with a consensus of what all the models are saying. Now, models are going to be completely different. The NAM is going to be different than the GEM. The GEM is going to be different than the American model, the European model, because all the uh, mathematical derivations, I guess you could say, but the derivatives that these models go through are totally different, and they're going to have different outcomes. Sometimes, and just even days out, models can be vastly different, which makes it very difficult forecasting. But we hopefully, as time gets closer to the event, the models be more consistent and they'll be more like each other. And that gives us a much better idea or more confidence in our weather forecast. So let's just kind of go through what the models have. So let's say, for example, we'll go to the GFS. And the GFS is going to go through, it's got all these different levels of the atmosphere. Okay, the 250 millibar, that's about 30,000 feet. 500 millibar, that's 15,000 feet. And that's the weather making basically level. Whatever happens at the 500 where the spins begin to occur, those translate all the way down to the surface. And that's where you get your low pressures developing. And that's where you get your snow, ice, and rain and thunderstorms. So, and then we got 700 millibar, which is about 10,000 feet. Then we got the 850, which is about 5,000 feet up. Then this is about 2,000 feet up, 950. And then we have the surface. And then we can kind of look at convective parameters. We can look at the shear. We can look at what supercells, if the models are favoring supercells or stuff like that. and then it actually shows the precipitation. And what I think most people would find most interesting would be go to the winter section here in the wintertime, hit precip type, and you can kind of see what's going on here. The green is rain, the blue is snow, this purple here would be freezing rain and sleet. So you can just kind of take it out for the next 84 hours on this particular model, and this it'll show you what it think is going to happen. Now, all this is based on, again, on what's happening in the upper levels that translate down to the surface. So let's just kind of take a look. So the 250 millibar, which is about 30,000 feet, this is a jet stream level. You can kind of see the jet stream there and where it dips and ridges and stuff like that. Where it dips is where you get spin in the atmosphere, and that's when you start getting your low pressure system develop. And the next level here is the 500. This is about 15,000 feet. And like I said, this is the weather making level of the atmosphere. We take a look at vorticity. Vorticity is spin in the atmosphere, and all the colors are different types of, are different levels of vorticity or different strength of vorticity. So we can move along this. You can just kind of see up in here the spin up here. That's where the coldest air is up there, and it looks like it's going to stay up there for a while. But as you see, as we move across, you can just move the weather through the next 16 days, and at the 500 level, it's just kind of showing you what it's thinking is going to happen. Okay, the 700 millibar, that's where I look at the relative humidity, because this is where the precip making or the snow making level is. Like snowflakes develop at this level, about 7,000 feet. It's called the dendritic growth zone, the DGZ, and it's usually between minus 10 and minus 20 degrees Celsius as you go up in the atmosphere. And that temperature range is where crystals can really develop and you can form a nice snowflake. So you can kind of watch this and just move that along like that. You can kind of see here it's trying to bring some moisture up here in the Missouri, and maybe bring in some rain as we head into the weekend. And then you just move it along and just kind of see what the weather's looking like there. The 850 is where I look at temperatures. Okay. This is for rain and snow, obviously. Basically, I'm looking at winter weather, and we'll go into springtime and severe weather forecasting when that starts occurring. But this is the 850, and this is the zero line. Anything north of that line is going to be less than zero. Anything left of the line or south of the line is going to be greater than zero. So you can kind of see that we're staying above freezing here at the 5,000 foot level. Maybe just get a glancing blow of cold air here as we head into the weekend. But it looks like anything right now, as far as cold weather, is going to be short term. Just looking at this, looks really mild there as we head into the first week of March. And there's a low pressure moving across here. That might kick off some thunderstorms as we head into, next weekend. And just kind of just move it along like that. And then the other level is 925, and then that's about 3,000 feet. And then you can kind of look at the surface, and you can look at your temperatures. And another thing you can do with this, you can move in, just go up here and you click that site there, and you can move right here and you can zoom in on a certain area. So you can really kind of see what's going on here. You can see what the temperatures are here in St. Louis right here. This is this morning. And as you move along, 24, it's got a high of 49 today. It's got a low of 43 tomorrow morning, and then 51 tomorrow afternoon. And you can kind of see where the temperatures in. Then by Friday, it looks like it's getting close to 70, 67. So a nice day looking up Friday and Saturday. And then again, cold front comes through, and we just kind of hang in the 30s. Nothing extreme cold, but it'll be chilly over the weekend. And you can see the warmer weather coming in. But that's just kind of what we look like right there. Look for right there. And every model is going to be different. The European's going to be, the 500 millibar is going to be different than what we see with the North American model or the Canadian model. So that, in a nutshell, is kind of what the models do and how we look at things. But as we get closer to an event, we can actually go into stuff and look at what we call the Skew-Ts. For example, let's take a look at one here real quick. The Skew-T is basically uh, a vertical profile of the atmosphere. So let's see here. Let's try to get one. This is, let's go to the American model. I can get access this. So let's see what there's some snow coming across here across the Northeast. So let's see what this looks like here as it does. It goes close to Boston here. So here's the Skew-T. This is the it's called the sounding, and let it load up here. And you can see here, so this is the sounding. This is as you go up in the atmosphere. These are your levels: 1,000 millibars, 850, 700, 500, 300, 200. And the red is the temperature. The green is the dew point, and you can kind of see the temperature and the dew point are together the whole way, and it's all below freezing. Here's your zero line. It goes up in a skewed fashion. That's the skew T. So this is your zero. Here's your -10. And as you go up, and this is your DZ, this is your DGZ, the dendritic growth zone, right through here. That's the yellow. You can kind of see, and it tells you that best guess is snow. But this is very important for anything from snow to severe weather. This is where you can really kind of take and look and analyze what's exactly happening in the column of atmosphere above you. And the last part, there's another place that if you just want to look at quick temperatures or stuff like that, it's called Albany Quick Look. You can look through here and you type in STL for St. Louis or wherever you're at. And then there's click like the NAM Moss is model output statistics. And you can kind of see what all these are doing. And it'll give you what the temperatures are expected. This is the short term GFS. It's got 35 tonight, 56, 36, 48. And then the long range, it takes you out 7 days. Kind of take a quick look at that. Cloud cover would be overcast, partly cloudy, overcast, clear, partly cloudy, so stuff like that. So this is overcast, so it looks cloudy over the weekend, and it's got some high probability of rain. And then this is the NAM, which is just that's the North American model, but they're all a little bit different. But just to kind of give you an idea of where you can just kind of take a quick look at temperatures. So um, I just want to wrap this up now. One thing I would like to say is, as far as TV meteorologist, um, Chris Higgins, if you follow anybody, he is by far the best pure meteorologist out there. So that's my 2 cents there. So I appreciate that. And thank you for watching. And hopefully I can get better at these as we move along. But I appreciate it. And thank you very much.